Hello, everyone. Welcome to the Tom's Hardware Podcast for July 19th, 2022. Sorry, we're starting a few minutes late. We had an issue with the Facebook setup, so we had to push it back 5 minutes. But as always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch, joined by Raspberry Pi expert Ash Hill and Associate Editor Les Pounder, and our very special guest, Anvil founder Meredydd Luff. Did I pronounce that correctly?
Sorry, we really should have rehearsed that one beforehand. Hi,
Yeah.
My name's Meredydd. Great to be here.
Awesome. So a lot of folks use Anvil as part of their projects, but for folks who might not be familiar with it, what can you tell us about yourself and about Anvil?
Sure. So Anvil is a platform for building web applications in Python and only in Python. So traditionally, if you want to build something that goes on the web, you can use it in a browser or from your phone. You'll need to know about HTML and JavaScript and CSS, and then Python for the server and SQL for the database, and then you'll need to know all the DevOps required to get it up and running. And Anvil lets you short circuit all of that by building the entire application with nothing but Python. Which is that's great. People use that for sort of startups, internal tools, dashboards, all sorts of things. But I am here very excited to be talking to you because what we did recently is release a way of making Anvil web applications talk to projects built with the new Raspberry Pi Pico. Because I assume you're sort of broadly familiar with the Pico if you're watching this.
Oh, never heard of it.
Yeah, absolutely. Well, if you haven't met one, they are incredibly cute. $6 microcontroller boards from Raspberry Pi. They, unlike the previous iteration of the Pico, this is the Pico W, which supports Wi-Fi. And obviously that invites a huge number of projects that might involve building something with this and then making it talk to the internet.
Mm-hmm.
And you might want to do some data logging. You might want to have button pushes someone can push on the internet and something actually happens in your house. Les was talking just before we came on air about controlling fans to reduce his temperature. If you haven't been following British media, I don't see why you should. We're currently in the all-time highest temperatures we've ever had in the UK, and I'm very grateful for my air conditioning. But if I didn't have one, I'd certainly want to be controlling some fans. And all these projects are obviously great, but the thing about driving something from the internet is that, oddly, something like the Pico makes the driving something part remarkably simple. Actually, I saw Les on Twitter just banging together a spare PC fan, was it? To keep yourself cool. Yep. And thinking about controlling that from the Pico. Those kinds of projects are really, really simple. And then you get to what ought to be the easy part, which is, okay, well, now I want a button on the internet that triggers this. And that is unaccountably very difficult. And so what we've done is we've released something called the Pico uplink, which is a way of making code on the Pico, written in Python, because MicroPython, everyone loves it, making that drivable from a application you built on the internet, all in Python with Anvil. So yeah, that's what I'm here to talk about and to show you guys, and I am very much looking forward to it.
You are muted.
Sorry. What are some of the things that you've done with it so far?
So far, I'm hoping to show you a couple. But so far, we've had driving Lego stuff that moves or changes when you click the button. We've got a little billboard thing for displaying messages entered via the internet. I believe I shouldn't be revealing this, but my co-founder Ian is probably working on the next generation of his bedside e-paper, e-ink clock for his partner that displays the time to the nearest hour, sort of 3-ish, 4-ish, 5-ish, and then a random Shakespeare quote, because she's a big Shakespeare nut. And that is currently running. The previous version runs on a Raspberry Pi 0W,
Mm-hmm.
and it's got the 3D printed thing where the Pi is on the back, and the ink is on the front, and of course a thonking great big lipo pack to keep a Pi Zero W alive for the amount of time to make it something a useful gift, rather than something that you run for an hour, it runs down, and then you forget about it.
Yeah.
And that is the kind of thing really for which the Pico is absolutely perfect. All you really want is an actuator somewhere out there in the world to do the thing that your application logic says you need to do. So yeah, those are the first few projects, but the Pico's only been, Pico W has only been out for a couple of weeks, so I'm sure we will think of more.
But Anvil's been around for quite some time. It's been working with boards. It's been with the Raspberry Pi for a few years now, at least.
Yeah. So yes, the Pico uplink that I'm going to be showing people today is it's built on top of something we already use, which is the uplink. So the idea with, as you'll see, I mean, I'm going to be doing some live coding today, in case people weren't forewarned. The Anvil applications are built entirely in the cloud, so they call it serverless. So you don't have to worry about setting stuff up and hosting stuff and installing stuff on your machine. You just go to a web browser, build your application, and it's hosted online. But obviously, you're going to need sometimes to control something that lives in a particular place. Maybe I want access to a particular database that's on this laptop in front of me.
Yeah.
And so we have something called the uplink, which is a library you can pip install from anywhere in the world. You connect that code running locally on your machine into the cloud, and now you can call code on your machine from your app in the cloud, and vice versa. And what we've done is we've enabled that for the Pico. So previously, you could use it on the Raspberry Pi, because the Raspberry Pi is, of course, just a Linux computer. And now what we've done is we've ported that to MicroPython, so you can get the same benefits without having to run a whole computer, and instead you can run something like this off a digital LiPo pack.
So what is the build interface like for creating something with Anvil?
All right, you know what? I think this is probably the point where I should stop start showing you.
It's a segue.
All right, okay. So I am going to share my screen, and I'm going to I'm just going to build something. So I have this Pico in front of me. But before we get into driving the hardware, let me give you a brief introduction to Anvil. Share my screen, see how well this works. All right, can you see my screen?
Yes, sir.
Super. Okay, so I'm just going to take you on a very quick whistle-stop tour of Anvil. So Anvil is something you can get to online at anvil.works. It is, of course, as the Wi-Fi has decided to start chugging now that I am sharing a screen. Come on. Please tell me the Wi-Fi is still up. It is up. It's loading nice and slowly. Superb. Have you heard of something called the demo gods? Because I think I have angered them.
Happens to me every time. Every time.
Podcast.
All right. Oh, I'm just going to stop sharing my screen and hit hard refresh a couple of times, and in the desperate hope that this is in fact going to make the thing that's been loading every time I tried it this afternoon work.
Curse of the live demo, mate. It always happens.
Yeah, I'm really impressed. Just completely failing to load something from the internet is working.
Are there any browser restrictions? Like, should you use Chrome over Firefox?
Yeah, you should. There we go. Wi-Fi has suddenly started working after hitting it with a large enough hammer. So it works. So the editor itself is works with Chrome and Firefox, and the applications you build with it work with every browser that's currently receiving security updates. So that's Safari, Firefox, Chrome, Brave, that usual set. Okay, apologies for that little delay. Here I am in the Anvil editor, and I'm just going to show you what it's like to create an application with Anvil. So what we have here is a web page. And over here is a toolbox of things I can put onto that web page. So for example, I want to put a title on my page. I'm going to drag and drop a label component up here. And then you can see I can edit its properties. So I'm going to go edit its text and say hello PiCast. Now that's pretty simple, but we can be a bit more interactive. So what I'm going to do is I'm going to put a card on here, have a button that does something when you click it. So I've dragged a button component on here. I edit the text to say do something. Make it a little bit nice to look at. And now this is where the fun thing is, because this is just building a web page. And obviously you could do that with HTML and CSS if you were willing to suffer the pain. But this is all backed by Python. So if I double click this button, I am now editing the Python code that runs when you click that button. So I'm just going to show you that by making the button pop up a message. So hello cast. And now if I run this code, click the button, pop up an alert. So you can see I've just built a little bit of logic with a drag and drop user interface. I've turned it into a working web application in like a couple of lines of Python.
So can you share that with folks and they'll see it on the web?
Yeah, absolutely. Let's do it. Publish this app. Choose a URL. Let's go with hello PiCast.anvil.app. Right. This is live on the internet right now. Pick it up on your computer, pick it up on your phone. It's a working application.
That's very cool.
So that was the whistle-stop version of Anvil. Obviously, you can do so much more with Anvil, but I'm not really here to talk about Anvil today. I'm here to talk about the Pico. And what we want to do is to make the Pico do something when we click this button. And to do this, we're going to use something called the uplink. So I can hit the add button over here, add the uplink to my application, and enable it. And what this does is it gives us an authentication token. And we can use that authentication token from anywhere in the world to link code running somewhere, in this case on my Pico, to the application that I've just built. So let's get ready to link our Pico to this application we've built. So to do this, we'll obviously need to install some software on the Pico. Your starting point for all of our Pico functionality is anvil.works/Pico, and there's an awful lot you can see here. You've got tutorials and examples and documentation. I'm just going to go ahead and grab the latest release. So I'm just going to download this firmware image, which is based on the MicroPython firmware image. It's actually got a whole bunch of stuff built into it already for driving some of the Pimoroni activities. And now it's time to flash my Pico. So if you can squint over here to the corner of the screen where my face is, you can see the usual game I'm about to play. I'm about to hold this boot cell button and then plug the Pico into my computer. And voila, it's shown up as an extra drive. And to install the Anvil firmware, all we need to do is drag and drop that firmware image we just downloaded onto that Pico. Again, none of this is going to be unusual if you've been playing around with the Pico for a while, but we have tried as hard as we can to make this pretty accessible for beginners. So, while this is flashing,
actually, Meredydd, while it's flashing, I just want to ask you a question. The version of MicroPython that you're using for this uplink tool,
again,
the version of MicroPython that you're using for the Pico W,
so this
I noticed
is
slightly different to the official MicroPython for the Pico W.
So this is in fact, yes, the build here is based on MicroPython, but as you'll see, we've made a couple of modifications, improvements to MicroPython, specifically to do with internet security. Because this thing is about to connect out to the internet. It's got an authentication token in it, and that needs to be secure and encrypted. And out of the box, MicroPython wasn't supporting that. And so we've made and contributed some changes back to MicroPython so that this can in fact be secured and relied upon, so you don't have to think about it.
Excellent.
Regardless, let's open up Thonny and look at what is in the Pico once we have flashed this image. Excellent. This is nope. This is not playing ball. I really did something to anger the demigods this time, didn't I?
I think you did.
It's okay. Once when I reboot this thing, it should show up. Haha. There we go, as a drive. Now we can open this from Thonny. If we reset this, now we can open this from Thonny. Open things from the Pico. Okay, need to Control-C this. Reset it. There we go. Fourth time lucky. Hooray! Okay, so if you install this firmware, what you'll get is a couple of files on your Pico. One is boot.py, which is a pretty simple, straightforward-ish piece of Python that will connect to the Wi-Fi. And this is just using ordinary the code you would write if you were building any wireless project with the Pico W. So I'm just going to stick in some credentials here. Okay, that part's pretty simple. The real fun is in main.py, which is this uses the Anvil.pico module, which is the biggest addition in the Anvil firmware I just installed. And this is a package that we can use to talk to an application built in Anvil. So you can see it expects an uplink key, and then we Anvil.pico.connect with that uplink key, and that causes the Pico to connect up to Anvil. And then we can do things like defining a function on the Pico that is callable from our Anvil application. So here, if we call it, it will print out a message on the serial console, and it'll blink the LED a few times. So let's just run this as is. Go grab our... I'm sure it was somewhere. There. No, not over there. There it is. Grab our uplink key, stick it into our code, save it, and then I'm just going to press Control-D over here to reboot the Pico. And you can see it's coming up. It's joining the internet. It's found an IP address. It's connected to Anvil. Bang! It's authenticated. And that's all we needed. That Pico function is now callable from the app. So let's go and do that. So we're back in the cloud. We are editing our application. We're editing the Python code that runs when that button gets clicked. And instead of popping that message, we're going to do anvil.server.call, and then we're going to call that Pico function we just defined on the Pico. It wants an argument. I'm just going to give it 42. And now, if I run this and click do something, over here in Thonny, you'll see it call the local function with argument 42. So we just connected our Pico to a web application and made it do something when we clicked the button. That is something that is actually remarkably difficult if you're using traditional technologies, and it happened pretty quickly, even with all the things in my setup that didn't cooperate today. So now, obviously, this is a rather boring thing to do, to ask it to put something on the serial console. So I have here an Inky pack, I think it's called, from Pimeroni. So this is another Pico connected to the back of an e-ink paper display. And we are going to make this Pico display a message from the web on the display. So I'm just going to unplug the my old Pico and plug the new one in. Now, this one I've already programmed with the Anvil firmware, so hopefully it should come up. See it? No. Yes. Okay. Right. It's up. Hooray. Okay. So I'm going to need to do the same dance. I'm going to have to put some Wi-Fi credentials into here. Okay. That's pretty straightforward. Now let's open the main.py file. Now I'm going to strip this right down to the bare essentials here. Okay, so we have our uplink key. And we connect with it. So let's put the uplink key in. Now, what we want to do is to display a message on the e-ink display when a function is called. Now, rather than writing all of this code for us, I actually have there we go. I have some sample code for displaying a message on the Inky hat right here. So I have this function display message. You can see it just initializes the pack, and then the user sets a font and updates it and draws a message in the nice place on the in a nice place on the screen. So what we're going to do now is we are going to write a function that's anvil.pico.callable decorated, which means to say this function is we can call it from the web, and we call it say something, and then it's going to take a message and it's going to print. Let's see, displaying message, and then it's going to call the display message function with that message. And that's really all we need to do. If I save this and I reboot my Pico, I've now got this say something function. Well, once it loads, there we go, it's connected to the Wi-Fi. This say something function can now be called from my web app. So let's go over here to my app and allow the user to enter a message to be displayed on the e-ink display. So we will want, say, us get a label to prompt the user to enter their message. I can absolutely spell. I'm going to have a text box here so they can actually do that input. I'm going to call this message box. So everything in Anvil on this page has a variable name, so we can access it from code. And then we're going to put the button over here and call it display message. Okay, so we've just built a slightly more complicated UI. And now when this function's called, we don't call picofun, we call, or what did I call that function? I called it say something. And instead of just displaying 42 every time, we want to display what the user has entered in that message box. And everything in Anvil is a Python object. So we can go self.messagebox, which is the text box component, and get text out of that box. And that's it. If I hold this up to the light and type PyCast, and hopefully you will see this as I click display message. There we go. So I've just put a billboard that displays anything that you enter in here. Now remember, this is actually live on the internet. So you can go to hello-pi-cast.anvil.app if you're watching this right now and put in a message. Please keep it clean for the stream.
Yeah, that's dangerous.
Yeah.
Come on, someone can do it.
Can you password protect Anvil apps or put some type of security?
There we go. Big Les P was here.
That was fast, Les.
Because there is, of course, exactly this problem that that anybody could currently go to this URL and vandalize my beautiful billboard. So let's go and fix that. So you asked about password protection. Excellent idea. So Anvil has built-in support for user authentication. So what I'm going to do here is I'm going to add Anvil's users service. And this is a full-featured login system. So you can use username and password, or you can do Google or Facebook sign in, or Magic Link, or if you are in a corporate environment, you can link to your enterprise authentication. I'm just going to configure it for a turn off email and password. I'm just going to turn on Google authentication because that's nice and straightforward. And I'm going to create one account, which is Meredydd at Anvil.works. Enable it. Right, okay, so somebody can now log into this app. So now I need to pop up the login form, which again, you can customize it, but it's all done for us if we just do anvil.users.login with form. So I'm going to go back to my page, and here is the Python class that is that page. And here is the code that runs when the form opens. So we go anvil.users.login with form. So now when I run it, it's going to prompt me to actually sign in. But that's only half the thing, because we also need to enforce that. So let's go back to our Pico code. And this anvil.pico.call, we now say require user equals true. And,
nice.
Okay, hang on. I'm gonna have to cancel the cancel the loop, run this, and reboot. All right, and now, if I were to try and call this function without being in a session that's logged in with Anvil's users service, then the Pico will not do anything. So, but if I log in now, there we go. I am logged in. Now I can type my name, and it will, in fact, work. So yes, you can password protect applications built with Anvil, and it's
very
really
nice.
quite straightforward.
That is straightforward. Normally, you think of authentication, you're delving through lines of code and libraries and modules. Whereas that,
And
just a few lines, it's done.
Because typically, if you think about authentication, it's not just the complexity; it's the fact that when you're writing lines and lines and lines of code, every line you write is an opportunity to get it wrong. And if you get something wrong when you're writing, I don't know, some ordinary UI code, then the problem is a bug in your UI. If you get it wrong when you're writing authentication code, the problem is anyone can walk through the door and steal the crown jewels. So yes, having that built for you is something that we, that we did to make things safer as well as easier. And again, this is why we have a custom MicroPython build that does TLS certificate validation for similar reasons, because previously validating TLS certificates on a microcontroller, I mean, it is possible. It's a real pain in the rear, and I don't think it was supported out of the box in any MicroPython build I'm aware of. And obviously that means that you're handing people sort of sharp tools they can cut themselves on. And this is actually not very helpful. So we put something that was, again, out of the box, did the right thing.
So I know that the Pico W is still fairly new, but with what you've done so far with it, is there anything you've wanted to create using Anvil and the Pico W?
So,
totally weird or cool?
I mean, there are, I mentioned a few projects that have happened or are on the way. I quite fancy making a little Lego car drive around. I think that's going to be quite fun. Ian's partner's desktop bedside clock is probably going to receive an update that lasts much longer on battery. My personal one that I would really quite like to play with is to control my central heating. So my central heating is a wireless 433 megahertz jobby. Run by a relatively dumb thermostat, and I have found a transmitter that will work, and I found some web page of somebody who claims to have reverse engineered the protocol for it. So I'm thinking that I could go out and put a temperature sensor in there and have my central heating controlled over the internet, so I can, rather than having to say, oh well, it comes on at 4 p.m. every day, I can say, well, actually, I'm going to be late tonight, or I'm on my way home early, and have the house actually be toasty when I get home. I mean, it's pretty much guaranteed to be toasty when I get home today, but under normal circumstances, the UK has more problems with cold.
Yeah, no question. What about data going the other way? How easy is it to take data from your Pico and send it up to Anvil?
Right, okay, well, you know what? This first Pico I picked up has a temperature and humidity sensor. So how about I just show you? So what I'm going to switch to plugging this one in, and I'm going to build like a little data logger that that logs the data from this temperature and humidity sensor into the cloud, and then we're going to have some fun with it on the UI. So here I go. The usual screen sharing dance. Cross fingers. Let's see if this one works. I think I'm live. Brilliant. Okay, so I'm going to switch back to our first Pico here. Okay, and switch it on. Now, in a moment, this is going to load. I should be able to connect to it from Thonny. All right. Okay, good. We are live. Now, let's open that main.py we had earlier. So this is the first one we used. So it's already got the uplink key and this callable function here. This is the sort of the default thing that it comes out of the box with when you install the Anvil firmware. So let's strip this down to the very basics. It's got an uplink key, and it connects. Now, we are going to make this log some temperature and humidity data into Anvil. So the first thing is we're going to want to create somewhere to log it into. So actually, you know what? I'm going to save this app. This is Hello PiCast. So this app is still live. It's still out there on the internet. But I'm going to go create a new one. So create a new blank app. All right. Okay, and I'm going to call this one the data logger. Okay, so one of the things that Anvil has is a built-in database, because data storage is a thing that you frequently find yourself wanting to do when you're building on the web. And you can, of course, use anything that Python can talk to. So, if you already have a database out there in, I don't know, Postgres, then you can talk to it. But if you don't, then creating a new database with a new table is as simple as hitting the Add Table button, and that's giving it a name. So this is going to be a table of readings. And we're going to have a few columns. So obviously, we're going to want a date and time column for when the reading was taken. We are going to want a number column for the temperature. And let's go with a number column for the humidity. Okay, right. So I've just built my database. That was fairly straightforward. Now we want a way of putting data into the database. So I'm going to go into my app. I'm going to create a server module. So far, everything we've been doing when we've been writing code in Anvil has been client code. So this is JavaScript code that's actually running in the web browser when you open your application, which allows it to drive the user interface. But here we want server code that's running on Anvil servers. And very much like what you saw me doing with the Pico earlier, I can write a function. So let's say def record reading, and it takes a temperature and humidity. And let's takes app_tables.readings, which is the table I just created. It adds a row where the when is date time.now, which I clearly need to import. And then the temperature is the temperature that was passed in, and the humidity is the humidity that was passed in. And then I can tag this function anvil.server.callable, which says that this function running out there in the cloud is something we can call in this application. let's fill in that import. Okay, so we now have a function that will record some data into this database. So we want to call that from our Pico. So let's add the uplink. We know how this game is played. Add the uplink, enable it, grab our authentication key, go and paste our authentication key into our Pico code. Now we want to run a loop that reads our temperature and humidity sensor and calls that record reading function. So this is a fairly standard sensor. So I'm just going to import the DHT22 class, and this one happens to be connected to pin 28. And we can now write a function that records a reading. So data. Oh. So this is just has a infinite loop, measures what the sensor is currently reading. Let's print that out. T equals temperature. T equals. Okay, so that's going to print out on the serial console, and then let's record it. So we could, just like we could do anvil.server.call there, we can do anvil.pico.call. And I need to go remind myself what I called that function. I called it record reading. And I think it wants temperature first, then humidity. It does. Sensor.temperature, sensor humidity. And then we can asynchronously sleep for a second. Okay, so this little routine will, in an infinite loop, measure the current temperature and humidity, and then call a function whose name needs to be a string to record that in the database. And what we can do is we can then pass the onFirstConnect argument to the anvil.pico.connect and say basically to launch this task first time you successfully connect to Anvil. We only need the once because the Pico uplink will take care of reconnecting if we lose and regain Wi-Fi. So in this case, we only want one to spin round. You can also write a function that happens, on every connection. So let's say you're building some unprivileged device, and there are going to be hundreds of these things out there in the wild, and you don't want to put any sensitive information on sensitive uplink keys on there. You can instead every time you connect, supply user account specific authentication information. There's a lot you can do with it, but let's just do the simple thing now. So we connect. As soon as we first connect, we start this infinite loop going. And I think, that is not happy. Let's reset our back end just in case. Okay. And save. There we go. Okay. So if I reboot this Pico, we should hopefully see it connect, and then once it's connected, there we go. Every second or so, it is recording the temperature and humidity. If we go over to our Anvil application, let's open that database table again. Oh, that is not working. Interesting.
Meredydd, it's not running.
What's not running?
The actual web app.
That's okay.
Oh, okay.
This is all sorts of fun. Let's see what our logs have to say. Okay. Uplink connection. So there was something that connected mere moments ago. It is calling record reading. Oh, That's why, because we need to await anvil.pico.call because it's an asynchronous function. There we go. Again, demigod strike. Save this. Reboot. Oh. Pico. Connected. Okay, there we go. Now, if we go back and look at our readings database, we can see the data is flowing in. So this Pico, right now, is recording live data into our database. Even better, this Pico actually has a Pimeroni LiPo shim, which means that I can unplug the USB, and it is going to continue recording. So let's sort by date descending. There we go. It's going to continue recording every second or so.
Very nice.
So, okay, now we've got that thing running. Let's see if we can do something interesting with it. Let's try and display some of this data. So, what do we want? Well, we're going to want to display some graphs on this page, which means we need some data. So let's start by writing a server function to return that data. So Anvil server callable, get data, and we're just going to return at tables.readings.search. So that's just searches every row in the readings table. Send it back to the client. And now we want to build our user interface to display that data. So let's put a couple of cards on here, one to display the temperature graph, one to display the humidity graph. Okay, let's have a plot object. So Anvil has native support for plotly plotting. So I'm just going to create two plots, one for the temperature, one for the humidity. I'm going to call this one temp plot, and I'll call this one hum plot. And let's mark these. So no, that is not where I want it to be. Try again. Put a headline in here to. There we go. This one is temperature. And this one is going to be humidity. So, okay, so what we want to do is we want to refresh this, let's say every second or so. So I'm going to add a timer component. And this is this will trigger let's say every second. And when this timer ticks, we are going to go call that get data function, and then we're going to display the data. So anvil.server.call the get data function in our server, from our server code, and then I'm going to plot it. So the temperature plot, the data on that temperature plot is going to be a plotly scatter chart whose x values are, so for every row in the data, which the data is all the rows in the readings table, if you remember. So the x value is going to be when, the date and time where that occurred. And the y value is going to be, in this case, the temperature. And let's say that the fill here is going to be 2, 0 in the y direction. And then we're going to do it all again for humidity. So this is the humidity plot, and the x-axis is still when, but the y-axis is humidity. Now, one more thing. This is triggering every second, so we don't want to display the loading spinner. So let's call silently. Okay, now if we run this, there we go. So we are now displaying live data that's coming off this Pico, which, remember, no hands, completely wireless. And to show you that it's live, I'm going to breathe on the humidity sensor. There we go. As you can see, my breath is both warm and humid, and we're seeing those lines go up in real time. So we have built a database-backed data logger using the Pico. It's because of the LiPo shim. It's standalone, and we've tested this. If you're recording data every 5 minutes rather than every second, this thing will run just completely naively with no optimization for about 12 hours. And that's, of course, before you get into things like going into deep sleep, turning off the Wi-Fi in between readings, or sending the Pico itself into deep sleep. So there's an awful lot you can do here. Where would I be if I didn't let everybody else play with this? So let's go with right. This is the temperature and humidity.anvil.app. And again, this app is live on the internet. If you're watching the stream right now, go to temperatureandhumidity.anvil.app, and you will see the live feed of the data that's coming off my desk right now. So yeah, you asked, is it possible to take data from the Pico into Anvil? I think I've answered that question.
Yeah, that is amazing. I can't wait to do some Anvil projects with this. That's absolutely amazing. Speaking of, before we go today, Les has an Anvil project that he has done.
Oh, go on, show me what you got.
It's so cool.
Do indeed. Yeah, so a couple of weeks ago, I got an Inventor 2040 W from Pimoroni. So I'll just bring this on the screen now. Hopefully the cursor live demo is not going to affect me as much. There we go. So there's Inventor 2040 W. So it's a Pico W in a custom board, which has connections for servos, RGB LEDs. It's got audio, motor controllers, you name it. It's got it pretty much. It's sort of the spiritual successor to the Explorer Hat Pro, which was released a few years ago now. So I've got this linked up to Anvil, and I'm just going to restart the connection so I know it's working, because the cursor to the live demo, and I have no firstborn to give, unfortunately. There we go. So I'm authenticated, and I'm on, and I'm going to go to my app and restart. So there is my app on the internet. It's actually live as well, and whether or not this is a good idea or not, let's just do it anyway. In the banners, I have saved. That is the link to go to. So you can go to impassionedtriflingfootball.anvil.app. That was a random name. I didn't choose that. And you can make lights and noise happen live. So go ahead and have a go. So I'll go to full screen so you can see it. We've got a Lego compatible servo.
That was me.
That was you. Lego servo here. We've got a DC motor. We've got rainbows built into it, some RGB. So press some buttons, see what happens.
I did that one.
There you go.
That's amazing.
It's all live. So I just had to play with it because I saw that it was so easy to use. Now, I've used Anvil a fair few times in my life. I've used it to control, what's it called now? Lego Spike Prime Kit, which was an STM32 based board, by squirting serial data over the web to make a paper aeroplane launcher in Lego years ago.
Oh,
hence this is a Lego kit I was using.
That would be so much easier now because you wouldn't have to squirt the serial data around.
Exactly. So just how easy it is to use. These are just the functions that Pimoroni provide in their example code. I haven't done anything special. Just gone to their code, got the functions that I liked, put them into my code, and just changed their names so I know it's like rainbow, motor, servo, and away I go. Really easy to do and great fun. It's nice to see that we can mess around with physical computing with a nice cheap board and some web software. Oh, someone's spinning the motor. But yeah, good fun.
That's absolutely fantastic. So
Avram, you can now build that robot you want to do.
Yeah, I mean, we've got to try this out because we have been using, my son and I have been trying to use Flask to do something with the robot, and the motors were not keeping up. So we will try Anvil instead. But I also can see a lot of great use cases for getting this information, for allowing things out on the web with this and getting some data on the web. So that is just amazing. I encourage everybody, whether you're using a Pico W or a regular Raspberry Pi or any Linux computer, to check out Anvil at anvil.works. Just an amazing tool. Thank you so much for joining us. Thanks to everybody for watching and listening. We will be back at 7:30 p.m. UK time, 2:30 p.m. Eastern next Tuesday, and we look forward to seeing you all then. Bye, everyone.